Good morning, friends. Welcome to online lecture series. I am Awad BG. Today we shall discuss about the topic number 3, that is motion in a plane. Now this is a last lecture of this chapter. Now in this lecture we discuss about centripetal acceleration. After that we also discuss about conical pendulum and revise all the chapter, and we also take some problems related with a motion in a plane. Before we start centripetal acceleration, first we have to study of centripetal force. What is the meaning of centripetal force? Now observe the figure carefully. Suppose the object is at point P and the object is moving along a circumference of a circle with some speed. Now here the force which is acting along the radius toward the center of the circle and which perform the circular motion is called as a centripetal force. Now we know, according to Newton's second law of motion, force is equal to mass into acceleration. If the force is equal to 0, acceleration is also 0. Means acceleration is depend upon what? Force. The centripetal force produces centripetal acceleration. Now one thing we should note that suppose the object is at point P, the object shows three type of acceleration. One is a tangential acceleration, another one is a angular acceleration along the circle, and third one is a centripetal acceleration along the radius, which is what? Along the radius. Means how to make a simple definition of centripetal acceleration from the given diagram. The acceleration of a particle performing uniform circular motion which is directed toward the center and along the radius of a circular path is called as a centripetal or radial acceleration. Now the name indicates that radial means along the radius. Radial means what? Along the radius. Such acceleration is called as what? Centripetal acceleration. Now which are the important points here to discuss? First, it is produced by a centripetal force. It means if the centripetal force is present at that time, only centripetal acceleration is present, and if the force is absent, centripetal acceleration is also absent. Now another thing is that in a uniform circular motion, which velocity is 0? Angular velocity is 0. Angular velocity is 0, therefore centripetal acceleration is what? 0. And angular acceleration is also 0. It means that centripetal acceleration is present in a non-uniform circular motion. It is present in what? Non-uniform circular motion. Another thing is that centripetal acceleration is present only in non-uniform motion. It is not present in a uniform circular motion. Now the mathematical formula of centripetal acceleration is AC or AR is equal to V square upon R. But we know linear speed V is equal to R omega. Now if we putting this value in the given equation, which is equal to R square omega square divided by R, R cancel, then final equation of centripetal acceleration is r omega square, means centripetal acceleration depend upon radius vector as well as angular velocity of a given body. Now AC is equal to r omega square.